triangles to find the values of x and y, and this question carries 3 marks. So we have a figure given here in which angle A is 90 degrees, angle C is 90 degrees, and this is angle x and this is angle y. So we need to find out the value of x and y. Okay, so since it's meant to have to find the solution according to the congruency of triangles, we can see two triangles here, triangle DAB and triangle DCB. We have angle DAB is equal to angle DCB, which is equal to 90 degree as given in the question. Side AB is equal to side DC. This is also given in the question. And the hypotenuse DB is equal to DB, which is common side. So we can say that triangle DAB, therefore triangle DAB is congruent to triangle DCB by RHS, right hypotenuse side. So we could say that angle ADB is equal to angle DBC, which is equal to 50 degrees by corresponding parts of congruent triangles. In short, we call it CPCT. So this angle would be 50 degrees. Now we need to find out the value of y. So that's quite simple. In triangle DCB, angle D plus angle C plus angle B should be equal to 180 degrees. Alright, angle D is y, angle C is 90, angle B we just found out 50 should be equal to 180. So y should be equal to 180 minus 90 minus 50. Therefore y is equal to 40 degrees. So the answer is x is equal to 50 degree, y is equal to 40 degrees. So the next question that we have here is from surds and indices topic. Now before solving this, I would like to tell you another rule, another law about surds, is that if a by b is given to the power of minus x by y, and if we want to change the sign of this power, we simply have to reverse the original number, like we take the reciprocal of it and it becomes x by y. Alright, the same thing will be applying over here. As it is written 8 by 27 to the power minus 2 by 3, if we need to change the sign of the power from minus to plus, we have to reverse the order of the number. So 8 by 27 changes to 27 by 8, and the power is now positive 2 by 3. Similarly, 1 by 3 changes to 3 by 1 and the power now becomes positive. And 7 to the power 0 remains as it is. Alright. Now, another rule says if a by b is to the power 2 by 3, it means a to the power 2 by 3 divided by b to the power 2 by 3. Right? So it is 27 to the power 2 by 3 divided by 8 to the power 2 by 3 minus 3 by 1 is 3 and 3 square is 9, we already know, and anything to the power of 0 is 1. Alright, so 7 to the power of 0 is 1, because any number to the power of 0 is 1. Alright, So 27 can be written as 3 cube to the power 2 by 3. 8 can be written as 2 cube to the power 2 by 3. And minus 9 and minus 1 become minus 10. So I'll erase this now. Now we have, see, when there's a power on top of a power, both the powers can be multiplied, right? So the next step will be 3 to the power 3 into 2 by 3. This power and this power will get multiplied. So now here we have 2 to the power 3 into 2 by 3 minus 10. This 3 and this 3 gets cancelled. This 3 and this 3 gets cancelled. So we simply have 3 square by 2 square minus 10. 3 square is 9, 2 square is 4, minus 10. We have 10 minus 40 divided by 4, which is a negative 31 by 4. So the answer to this question is minus 31 by 4. The next question is, find the value of a and b if 2a plus b comma a minus 2b is equal to 7 comma 6. This question also carries 3 marks. So we could say that this is nothing but 2a plus b, which is equivalent to 7, and another equation a minus 2b equivalent to 6. So there could be different ways of solving these type of questions. We could modify any of the equation to get our desired result. So what I feel is, I will multiply the second equation by 2. Alright, so I get 2a minus 4b is equal to 12. Now I will solve this equation and this equation. Alright, so we'll solve it. 2a plus b is equal to 7 and 2a minus 4b is equal to 12. We subtract. Alright, we subtract these two equations. So this becomes minus, this becomes plus. 2a and negative 2a are cancelled. B minus of minus 4b becomes plus, so this becomes 5b, and this will become minus, this becomes minus 5. So b is minus 1. Alright, so we put the value of b in any of the equations to find the value of a. So we write, putting b is equal to negative 1 in equation 2a plus b is equal to 7. So 2a minus 1 is equal to 7. 2a is equal to 8, a is equal to 8 by 2, that is 4. So ultimately a is equal to 4, b is equal to negative 1. This is going to be our answer. Next, show that the quadrilateral with vertices 0, 0, 5, 0, 8, 4 and 3, 4 is a rhombus. Also find its area. Okay. Now a rhombus looks somewhat like this. The properties of the rhombus are all four sides are equal, diagonals are not equal, but diagonals are perpendicular bisectors, and the area of a rhombus is half into the product of diagonals, right? So if we name this vertex as 1, A, this B, C and D, so we could write the coordinates of the vertices as mentioned in the question: 0, 0, 5, 0, 8, 4 and 3, 4. So how could we prove that this quadrilateral is a rhombus? We could prove this by if sides AB is equal to BC is equal to CD is equal to DA, and diagonal AC is not equal to BD, then ABCD is a rhombus. Okay, we need to check whether the distance between these two points, these two and these two, like distance between AB, BC, CD and DA is equal or not. If the distances between the given points are equal, then the second check that we'll do is whether the diagonals are unequal or not, because we know that in rhombus the diagonals are not equal. So if these two checks are done, we could determine whether this shape is a rhombus or not. And if this is a rhombus, we could find its area by multiplying the diagonals into half. Alright. Now there's a distance formula. Suppose we need to find the distance. So the distance formula is under root of x2 minus x1 plus x2 minus x1 whole square plus y2 minus y1 whole square. Or we could say the differences between x coordinate, we could say the difference of squares of x coordinate plus the difference of y coordinate square, right? The difference of x coordinates squared plus the difference of y coordinates squared. This could be summarized as this. Alright. So we know that in coordinate geometry, this is called the x coordinate and this is called the y coordinate. The first number represents the x coordinate, which is also known as the abscissa, and the second number is on the y coordinate, which is also known as ordinate. So I'll erase this and we'll solve and check whether this shape is a rhombus or not. Before that, I want you to copy this distance formula if you are not aware of this. Now, if you have any doubt, you could pause the video and rewind the video at any point and clear your doubt once again. So first we'll check the distance AB. The distance AB is under root of 5 minus 0 squared plus 0 minus 0 squared. This is 25, alright, which is 5. So AB is 5. Now we'll check for BC. BC is under root of 8 minus 5 squared plus 4 minus 0 squared, which is 3 squared plus 4 squared, which is again 25 under root, which is 5. Ultimately BC is also 5. CD. This distance CD is 8 minus 3 whole square plus 4 minus 4 whole square, which is under root of 25, which is again 5. And distance DA is 3 minus 0 whole squared plus 4 minus 0 whole squared, which is again 3 square plus 4 square, which is again under root of 25, which gives us 5. So the first check is done and we see that all the four sides are of 5 units length. So there is a possibility that this shape is a rhombus. So we'll perform the second check and we'll see whether the diagonals are unequal or not. Now, first check we'll do for the diagonal AC. AC is equal to under root of 8 minus 0 squared plus 4 minus 0 squared, which gives us 64 plus 16. Alright, which is 80 under root of 80. Now let's see what we get from BD. BD is under root of 5 minus 3 whole square plus 0 minus 4 whole square, which is 2 square plus 4 square, which is 4 plus 16 under root of 20. So the second check also tells us that the diagonals are unequal. So it is confirmed that the shape is a rhombus. It has been proven that the shape is a rhombus, definitely. So now we'll find out the area. The area will be half into diagonal 1 into diagonal 2. Alright, so let me erase this all and we'll straight away find the area. Just remember, first diagonal is under root 80 centimeters or under root 80 units, and the second diagonal is under root 20 units. This we need to remember. Or better, I'll keep it on the screen here. So area of rhombus is half into the length of diagonal 1 into the length of diagonal 2. So we have half into first diagonal is under root 80 and second diagonal is under root 20. So this gives us half into under root 160. Half into under root 160 is 40, which gives us 20 square units. Alright, so the area of this rhombus is 20 squared units. We'll solve the remaining paper in the upcoming videos. Till then, stay tuned. If you like our videos, don't forget to click the subscribe button and please share our videos with your friends. Thank you.